So what is artificial intelligence? Let's talk about that. So artificial intelligence, by the definition of the Webster Dictionary, is an area of computer science that deals with machine learning and the ability to seem like they have human intelligence. Well, that's a bunch of fun words that says you build a computer that acts like a human, right? So there's many other complex descriptions of what artificial intelligence is, and a lot of them, honestly, they either bore me or they lose me over the first 5 seconds. And so I'm going to try to break it down into a level that is understandable. Back in my day, in the 8-bit day, the Super Mario first gen kind of days, well, there was some very simplistic games that came out. There's games that when you hit the right button, the car goes forward, and when you hit the left button, the car goes backwards. And whenever you go and hit the right button and you go across the finish line, you win the game. Now, if I were to create a computer program to mimic myself, I would write a computer program that says when the program starts, when the game starts, hit the right button, hold it down until you cross the finish line. Pretty simple logic. And that is a computer program that is not artificial intelligence. It's a binary set of codes that allows the user to drive that car directly across the finish line. But if it was a more elaborate game where the car had to weave around cones before hitting the finish line, I could also create a computer program that does the same thing. I could say go forward 5 inches, turn left, go forward 5 inches, turn right, go forward 5 inches, turn left, and then go forward 5 inches until you cross the finish line. Most Lego Mindstorm kits are built in this fashion. So you program a robot to go forward, take a left, go forward, take a right, until you cross the finish line. You repeat that over and over again. You might have not wanted to go forward 5, you might need to only go 3. So then you modify the code to keep modifying it until you actually accomplish the goal. Again, that's not artificial intelligence. However, if I take it back to the binary left and right code, I could program the computer and give them inputs that says you can either hit right or you can hit left. And I can program the goal is to finish the game. And the more it goes forward, I will reward the computer program and say that run was better than a previous run that was less of a distance to the finish line. I could put in these parameters and then hit the go button and allow the computer program to experiment and to run multiple iterations, allowing the computer to test. If I hit right, I get a better result than if I didn't hit right. If I hit left, it continually creates a worse case scenario where I actually get worse. If you feedback that logic, or if you feedback those wins and losses to the computer program, it's going to analyze which ones did better and which ones did worse. The next iteration of the test runs that the computer wants to run, it will favor the test runs that did better on the last run. So if it was going to the right and it finally stopped right there, then it's going to redo that and then add something else to it. Maybe more rights, maybe more lefts, and then analyze again whether or not it did better or worse. These are human testing. And how did I learn how to play this game? The same result. the human that sat down to play the game with the remote tested left and right, and then finally realized that going right was going to take me across the finish line. Now, I did that very quickly. The computer took multiple iterations to get there. Now I'm going to take you to a video of Seth Bling. Seth Bling was a big computer scientist before he created a YouTube channel and did a whole bunch of Minecraft Redstone stuff. And he got pretty famous on YouTube, so he continues his career in YouTube and not in computer science. But he still has the heart of a computer scientist. Now, what he did is he took a more complex game, not so much going left and right, but you can see here the first iterations of his design. And what it did is multiple iterations of it not doing anything. Then it analyzed going right was a better scenario than sitting still or jumping in place. Then it got more intelligent. Then it realized that not only do I have to move to the right, but I also have to jump over the objects that are in my way. So instead of going and hitting the wall and stopping, it had to know that it was coming up to a wall and then had to jump over the wall. Well, that's a whole nother iteration of combining the right movement with the jump button and knowing when to hit the jump button so that you clear the wall instead of jumping too late and hitting the wall and not being able to get over the wall. So through multiple iterations, it continued on, and I'll show you that clip here. It continued on to go across the Mario world, jump after jump after jump, moving right the entire time, pausing for certain jumps, and continue on and completing the mission, which is clearing the goal. Now, to me, this has been locked into my brain the minute I saw this video. Now, he's done some fancy programming. There's a neural network that's analyzing whether or not it's doing good or bad, which code to mesh together and which code to let die, and which test runs were good and which test runs were bad. So the neural network is doing all that analyzing, and that is the artificial intelligence. It's the analyzing of the test runs just like a human would by going across the board and analyzing whether or not you're doing better or worse depending on what you did that run. So what Seth Bling has done is he's created a computer program that's thinking for itself and analyzing the results of the test that it runs. Through multiple iterations, it's allowing the program to learn how to play Super Mario. And it's an amazing feat. That makes it so that you can really computer program anything to allow it to learn how to do something. And on top of that, through more iterations, it will learn to do it faster and faster and faster and faster until it figures out the perfect scenario that allows that Mario to jump across the world as quickly as possible or get as many coins as possible, depending on what your criteria is set at. So it has multiple iterations built into it that allows you to say it's mimicking human intelligence. It's learning from its mistakes and it's applying what it learns to the next iteration or the next test run, which is what we do every day. We're a little more intelligent and we have more background when we go towards a problem than a brand new artificial intelligence program that plays Mario. If you take this Mario artificial intelligence and you apply it to the next level, it's going to know the rules that and the mistakes that it had in the previous levels, and it's going to apply that to the next level, and that's going to play out that level maybe faster than somebody that's a human that is just now playing the first and then the second level. And even a simplistic artificial intelligence program that is programmed to play Mario could be applied to other Mario games, could be applied to other video games, could be applied to other functionality that we have not yet seen. Just that little bit of artificial intelligence allows this computer program to be smart and to take its knowledge to another level, level 2 or level 3, or another potential problem that you have to solve. So hopefully that explanation is simple enough for somebody that doesn't know about artificial intelligence to learn about what it really is. And if you want to have a conversation about that, leave a comment down below. Love to hear about it. And if you want to learn more about what artificial intelligence can do for you or your company, reach out to me at Step Next Training, and I'd love to have a conversation with you or your business about how you can bring artificial intelligence into your company. So thanks everybody for watching. I'm going to leave a link down below to Seth Bling's videos, and if you want to see a lot more of the background and the math behind the computer program, please go watch that. And I want to thank you for tuning in, and if you like this video, please give us a thumbs up. And I'll leave you with this: make, share, and repeat. Thanks everybody for watching. We'll see you next time. Bye-bye.